So as we know that in last class and all, we studied what is introduction of gravitation and what is the theories that have been proposed about this gravitation before motion of the planets, how they are, what is the position and what is the force present between them and etc. And as we know, the scientist name called as Mr. Johannes Kepler, he analyzed the observations of his master. What's his master name, Mitakshri? Master of Kepler's. Tycho Brahe. So with his observations only, Mr. Kepler has proposed 3 laws about planetary motion, and as well as, of course, it is applicable to all the objects in the universe. So that is only laws we used to call it as Kepler's laws of planetary motion. Is it yes or no? Now, in the 3 laws, the first law which we already studied in the last class, the first law we used to call it as, what is another name of first law? Anybody? Yes, please. First law. What is another name of first law? Law of orbits. You take the law of orbits. So as we know, always the planets are revolving around the sun in a particular orbit, and this orbit is having what? That orbit is having 2 kinds of axes, perpendicular axis. What is that axis we used to call it as? Everybody?
Major axis, minor axis.
Is major axis. Another one is called as what? One is
minor axis.
Minor axis.
Another one is called as minor axis. So now, and as we know that major axis we are having 2 things. That is only we used to call it as, what we used to call? Focus 1 and focus 2. Major axis. Now, Gokul, sun will be present where? Is it at F1 or F2 or anywhere? Yes, please. What is Kepler's first law? Everybody. Sun is present at maybe at F1 or maybe at F2, and planets are revolving in a particular orbit. So that orbit also what shape it is? Elliptical shape. So that is only we used to call it as law of orbits. So what do you mean by first law? Open your mouth. Simply don't say that is what I don't want. What is according to the Kepler's first law? What it will say is, guys, everybody, all the planets revolve around the sun in different elliptical orbits, and the sun is located at where, guys? Sun is located at where?
Any one of the foci.
One of the foci of the orbits. Understand, Mr. Reddy? So we are having totally 2 focus. And what is the plural form of foci? A focus. So focus, the plural form is called as foci. Now what is Kepler's first law? Sun is present at either at F1 or at F2. We don't know. Maybe he can present at any one of the foci, but planets are revolving around the sun in a particular which orbit? Elliptical orbit. So that is what we used to call as law of orbits, or we can say Kepler's first law of planetary motion. This is what we studied in the last class. Is it yes or not? Divya? Yes, please. Everybody. So Kepler's first law will says that sun is present at any one of the foci, and planets are revolving around the sun in an elliptical orbit. That is only known as law of orbits. Is it okay, guys? Yes, please. Now,
Yes, sir.
if we take, then let us study the second law. That is what Kepler's second law of planetary motion. Also we used to call it as, please write it all of you, law of areas. What is to call? The second law is called as Kepler's second law is also known as law of areas. Shall we start now? Everybody? Yes, please.
Yes, sir.
So observe very carefully. Let me draw now. If you imagine the path or the shape, the path taken by the planets around the sun is circle or spherical in shape. Now, imagine sun always will be in where, guys? Where is the sun always? Where is the sun always? That is what my question. Everybody? Sun will be in where? Sun will be in center. Understanding? And planets are revolving around the sun in a particular orbit. That is what, if you'll consider, sun is in center and the path taken by the planet is circled. What is that? What is that, guys? Tell me that at least, please. If we'll consider as a circle, then if you'll notice it very carefully, this is the planet and let me take, this is the sun. Now, you tell me what is the distance between the sun and the planet always, if it is a circular path. If it is the circular path, if it is a circular path, then what is the distance between the sun and the planet always? That is what my question. Please answer. Equal. Understand? You might be imagine planet is here, or you 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 imagine planet is here. Wherever the planet is revolving around the sun, always the distance between the sun and the planet is same or different. The distance between sun and the planet is same or different? I'm asking. Yes, please.
Same.
Same. When if you consider a circular path, is it yes or no, ma? Everybody, respond, please. Yes or no?
Yes, sir.
Now, let us imagine now the sun is here. Now sun is here. The planet is at point A. What point, Mitakshri? Point A. Okay. Now, after some time, the planet reached to point B. Planet reached to where? Point B. I understand, Amma? Please.
Yes, sir.
Now the point, initially where is that planet, Mr. Harish? Point A. I understand? Now, I am joining the line between the planet and the sun. I am joining the line between the whom? Planet and the sun. Is it okay, Mr. Hari? Now, after some time, the same planet reaches to the point B. Now, at that position, also I am joining the sun and the planet. Sun and the planet. Now, observe very carefully. If I'll make it this, what is this point? Everybody tell me. What is this point, guys? Point B. I understand, everybody? So that is our understanding. Initially, planet as point A. Now it will reach us to which point?
Point B.
Point B. Now, if I'll join a line, imagine a line between the sun and the planet. Now, this looks like a something. Have you noticed it? From here to here, it is traveled something. Means in the sense of, it is covered some distance. Is it yes or no, guys? Is it will cover some distance or not? Yes, please respond.
Yes,
Yes, that is what. Let me consider that area is A1. That area is how much, Hari? A1. Now from here to here, the time taken is same. It's constant time period. Constant time. So let me take, for example, I am taking 2 seconds. How much it is? 2 seconds. Now, the same planet will comes to here. The same planet will comes to here. Just all of you observe. Now the planet is I'm taking here. Oh, just a minute. Now I'm taking the planet. Now the planet position is here. Let me take that point is C and D. C and what is that points? This point is C and D. Different days, different positions, sun will be, planet will be present. Now, I will join the line between the sun and the planet, and I'll join the line between the sun and the planet. Have you noticed it, everybody? Yes, please respond. Yes, Mitakshri?
Yes, sir.
Yes. Now, let me consider here also the time taken from C to D is also same. The time taken to travel from A to B, which is equals to the time taken to travel from where to where. If you are answering, it will be easy. C to D. It's not at all there for you, your book. You never even understand if you'll read. That is what I'm saying. From A to B, the time taken to travel from A to B, time taken from A to B, and time taken to travel from C to D is both are what? Let me consider this is T1 and this is T2. So both are what it is? Ready, I'm saying? Both are what it is?
Equal.
Equal. Now you tell me, if the time is equal and always the planet is same distance from the sun, then the area covered by here also, is it same or not? That is what my question. Is it same or not? Yes, please, everybody. Gokul, Akilan. If the sun is traveling, planet is traveling from A to B, then again from C to D, at the same time, constant time, then the area covered by, if I'll join the line between the planet and the sun, if I'll join the line between the planet and the sun, the area covered in this point from A to B and the area covered between from point C to D is A1 and A2. Now, these areas are equal or not? That is what I am asking. Yes, please. Yes,
Equal, sir.
all of you. So then the area swept by the planet, understanding? The area swept by the planet in both the cases is same or not? From A to B and B to C. Yes, please, A to B and C to D. Yes or no?
Yes, sir.
Yes?
Yes, sir.
Because I consider which path? Which path it is?
Circular path.
Circular path. So always the distance between the sun and the planet is same or different? Sun and the planet.
Same.
Same, sir.
So that is why always it will cover equal distance in equal interval of time. Is it okay, everybody? Yes, please. Respond, guys.
Yes, sir.
Yes. But if you consider original path, is it the original path is the circular path or elliptical shape?
Elliptical.
Elliptical shape or original path? Answer to my question fastly.
Elliptical.
Elliptical.
Now, let me consider, is it the sun and the sun and the planet, is it always the same distance or variable distance?
Variable distance, sir.
Variable distance. See, till now what we studied last 20 minutes, nothing is related to Kepler's second law. Just I am imagining if it is a circular path, always the planet is always in the same distance away from the sun, so that it will travel always equal distance in equal interval of time. Is it yes or no, guys? Yes, please. But
Yes, sir.
if it comes to the original path, Mr. Gokul, what is the original path, everybody? It is a what, guys? Elliptical. Elliptical path. Now, sun is present at any one of the foci. So let me take sun is present at somewhere. He is present at F1. Where he is present now? Where he is present?
F1.
F1. So let me take, this is the sun. He is present at where? He is present at where? F1.
Yes, sir.
Understand, everybody? So I'm considering very, very small so that I can able to see the sun properly. Is it okay, guys? Okay. See, to make you understand, I am drawing it more because you have to feel it like a original. That is what. Now, let me take now. This is only, I will take it as a planet and I will keep it there. Now the planet is at this position. The planet is at what now? This position. Are you understand, guys? Now he is near to the sun or far away from the sun?
Near, sir.
Near to the sun. Now let me take the sun is at same another position. That point is called as B. Okay. Now the sun is at another point. The point is at C. Now the sun is at another point. The point is at D. Now the sun is at planet. The planet is at another point. The point is at here. Now the planet is at another point. The point is at here. Are you understand, everybody? Yes, please. Hari?
Yes, sir.
Yeah. Observe very carefully. Is it the planet is always in the same distance away from the sun or different distance?
Different
Different.
distance.
Different distance. Let me take now A to B. This point is A and B. This point is C and D. And this point is E and F. Is it okay, Mr. Reddy? Very, very important. Very, very beautiful scenario. Now, as I told you in the last class, after ending the first law, I have taught you one point. Can anybody read that point? Most of you have taken the notes. I have taught you one point. Why a planet revolves around the sun in an elliptical orbit? Mr. Harish Jairas, can you tell me?
Yes, sir.
Point. You have written
When the
that
planet revolves around the sun in the elliptical orbit, the length of the shortest line joining a planet and the sun is not
planet
a
and the
constant.
sun is
It's not constant.
It is
It's
not
not constant
throughout the elliptical
throughout
path.
the elliptical path.
Is it
Yes,
right
sir.
or wrong? Everybody, Mitakshri? No response at all. Now, if I
Yes, sir.
let me join. What I'm saying, the shortest line, if I join a planet and the sun, understanding in an elliptical path, that is not constant throughout the shape. It is that is it the true or not? Now I joined A to B and B to A. Now B to sun. Understand everything. Now let me join all the things. Everybody tell me, is it constant? Is it same or different?
Different, sir.
Different, sir.
This is the sun now. Okay. Now from A to B, next I will join. Everybody join. You draw along with me. I'm drawing you correct for your purpose only. I'm drawing to make you understand. Now C point I join. Next, which point I can join?
D.
D point. Let me take now C to D now. Okay, everybody. Next which points?
E.
Divya. E point.
E point and F
Next
point,
which
sir.
point?
F point.
F point. So let me join this all the points. Now you can see. So now, is it always the line joining between the sun and the points, planet? Is it always equal distance or is it the distance is same or varies?
The distance varies, sir.
Varies. Sometimes the planet is coming closer. Sometimes the planet is moving away from the sun. Is it yes or no, guys? Is it yes, sorry?
Yes, sir.
Yes. Now,
Yes, sir.
observe very carefully. I want to teach you one point here. Whenever the planets are closer to the sun, more gravitational force of attraction so that the planets will run faster. They will travel faster. When? They will travel when? Faster. When they are closer to, closer to sun.
When they are closer
Understand?
to sun.
Yeah, the planet, if the planet is closer to the sun, it will travel faster. Planet is faster when they are closer to the sun. Due to the what force? Due to the greater gravitational force. Please note it down. Gravitational force. Now, the same planet will move slowly. The speed will decreases. Planets move slowly. Planets move slowly when they are far away from the sun. Far away from the sun. Due to what? Due to less gravitational force or more gravitational force?
Less gravitational force.
Less gravitational force. Understand, Mr. Arun Kailash? Divya? Akilan, that is
Yes, sir.
now observe very carefully so that you tell me now in which position sun will travel faster, sorry, planet will travel faster, and which position planet will travel slower.
Sir, A point it will travel faster, sir.
A to B it will travel faster, C to D little less, and E to F it will go very slowly. Is it yes or no?
Yes, sir.
Yes, because A to B, sun is very closer to the planet or very far away from the planet?
Closer to the planet.
Closer to the planet. Do you understand, everybody? So in this case, from A to B, observe very carefully, I am shading now. From A to B, the sun the planet will travel faster or slower?
Faster.
Faster. Now let me take from A to B and B to A, C to D and E to F. Time remains same. What is what? Time is remains constant. Remains constant. Are you understand, everybody? Time is what? Remains constant. But from A to B, he will travel more distance. Is it yes or no, guys? Yes, please. Next to C to D, he will travel little less distance. But E to F, he will go minimum speed. So he will travel less distance. Now, what is the point we studied in the last class? Last yesterday notes. Read that point, everybody, again. Everybody. While a planet revolves around the sun in the elliptical orbit, ready, note it down. While a planet revolves around the sun in an elliptical orbit, comma, the length of the shortest line joining the planet and the sun is not constant throughout the elliptical path. That is what we studied. Is it yes or no, guys? Is it yes or no?
Yes, sir.
Now, from A to B, I have taken the same time. Are you understand, everybody? I have taken the what? Same interval of time. Understand, Mitakshri? So here also time interval is same.
Yes, sir.
Time interval is same. And from C to D also what? C to D also what? Same time interval. And from E to F is also what, guys?
Same time.
Same time intervals. Time intervals. Now, let me take from A to B, the area covered between the sun and the planet. If I'll join the lines, let me take A1. What is that? What is that?
A1.
A1. Understand, everybody? Now, if I'll take from the C to D, let me take that area covered by that is what I can consider. You tell me. A2.
A2.
What is that area? Only in between the lines, Amma. You have to do in between the lines. For me, it is coming out, but you have to do only between the lines. It will sweep A2. Now, E to F. U to E to F. Let me consider the area. What will consider the area? So let me consider
A2.
E to F, the area, consider the area covered by the planet and the sun is, if we take, it will sweep the area of, what is the area you want?
A3.
Now,
A3.
notice it very carefully. A1, A2, A3. But time interval is what? Mr. Harish, Akilan, time interval is what? Time interval is what, guys? Ready? Answer. Same. If it is planet is same distance away from the sun, then it will cover equal distance or variable distance.
Equal
Distance or variable distance. Yes, please. Equal distance. Now, if it comes to the elliptical path, now is it the area is remains same or varies? Of course, may the planets will travel faster when they are closer to the sun. They will travel slower when they are far away from the sun. But now if we join the line between the sun and the planet at different positions, now if you calculate the area between them, then is it the area is remains constant or varies? Yes, please. Everybody,
Varies.
what is your expectation? Mitakshri, Divya.
So what is the question, sir?
Now, is it the areas are equal or not in elliptical path? Of course, circular path. If it is circular path, areas are same or not? If
Yes,
it is
sir.
circular path,
Same, sir.
areas are same. Now it is elliptical path, areas are same or not? That is what my question. Yes, please. Anybody?
Sir, areas are different, sir.
Yes, what is your guess, guys?
Sir, areas are different.
Areas are different, but that is only Kepler's second law. Even though the sun is sometimes far away from the planet, sometimes near away from the planet, but in a given interval of time, given interval of time, maybe the planet is moving faster when it is closer to the sun. Maybe it is traveling slower when it is far away from the sun. But the area swept by the planet means when you join the line between the sun and the planet, between a given interval of time is always remains same. If you calculate the area of A1 and if you calculate the area of A2, its looks may varies, but remains what is that areas? They will sweep equal areas in equal interval of time. Do you understand, Mitakshri? That is only called as Kepler's second law of planetary motion. That is why this law, what is another name of this law? What is another name of this law? Law of areas. Are you understanding? So always the planets will sweep equal areas in equal interval of time. That is only called as second law. Kepler's, what law is to say? Kepler's second law.
Second law.
Understand, Amma? Everybody, please respond.
Yes, sir.
Yes, that is what it is. So please make it. I hope everybody understand, Mr. Gokul, Mr. Harish Jairaj, Harish, all.
Yes, sir. Understood, sir.
That's all. So draw the diagram beautifully and make it everything, and I will say the definitions. Write it. Divya, understand, Divya?
Yes, sir.
So now the line joining the sun and the planet. What is the joining sun and the planet lines? Tell me first line. To take this is S. So what is that? What is the triangle now? SAB. Next triangle. SCD. Next triangle. SEF. Understand? So the area of SAB next is equals to area of what? Area of SCD, which is equals to area of SEF. Is it okay, Ma? That is only called as Kepler's second law of planetary motion. Hope everybody understand. Now, do you understand why I said the circular path, Harish?
Yes, sir.
That is what. So because directly you can say the definition, you people cannot understand anything. So that is why circular path, if you will study. So for example, time period, let me take 1 month. If you want, how much the time period I have taken? Same interval of time. How much I have taken? 1 month time. Do you understand it? So 1 month time, whatever the position of the planet, if 1 month, if it will cover say some area, then the next wherever the position, if it is the after 1 month, it will sweep same area from the planet and the sun. If you will join the line, imaginary line, remember that. Okay, everybody? Yes, please.
Yes, sir.
Yes. Can I say the definition now? Mitakshri, Akilan, that is what.
Yes, sir.
Write it. Write it. According to Kepler's second law of planetary motion, what is another name of planetary motion? Second law?
Law of area.
Law of areas. Right. According to Kepler's second law of planetary motion, according to Kepler's second law of planetary motion, Mr. Arun Kailas, you understand or not? Let me know.
Yes, sir.
Right. According to Kepler's second law of planetary motion, comma, a planet revolves around the sun. A planet revolves around the sun. A planet revolves around the sun in such a way that 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 the line joining the sun and a planet, is it an imaginary line or is it existed line?
Imaginary line.
Imaginary line. The line joining the sun and the planet, the line joining the sun and the planet covers equal areas in equal interval of time. Covers equal areas in equal interval of time. Have you understand everybody now?
Yes, sir.
Yes. Equal intervals, sun and the planet covers equal areas in equal interval of time. Equal interval of time. Diagram you draw, I think you already drawn, but right. Consider a planet revolving around the sun. Consider the planet revolving around the sun. Consider the planet revolving around the sun is its elliptical orbit. Sun in its elliptical orbit. Elliptical orbit. Consider the positions of the planet at equal interval of time. Consider the position of the planets at equal interval of time. What is the interval of time? Suppose we assume how much? How much, guys?
1 month, sir.
1 month. Consider the positions of the planet at equal interval of time. Say 1 month. 1 month. 1 month. Then the lines joining the sun and the planet. Then the lines joining the sun and the planet. Then the lines joining the sun and the planet. Sun and the planet at these positions are. At these positions are. What is the lines we assumed? Tell me. Everybody fastly. What is the lines? At these positions are, what is the first line? SA, second line, SB, third line, SC, fourth line, SD, fifth line, SE, and sixth line, SF. Write it all the things. S means what? Sun. Write it. Positions are SA, SB, SC, SD, SE, and SF. Capital letters, everything. Gokul Purima, Gokul.
Yes, sir.
Purima. Understand? Mitakshri, Divya. Now, according to Kepler's second law of planetary motion, what is that? Tell me. The area of the sector SAB. The area of the sector SAB. This is the area of sector SAB. This is the area of sector SCD. This is the area of sector SEP. Yes, sorry, SEF. Is it all are same? All are equal or different?
Equal.
Sir.
Equal, sir.
Right. Respectively, have you written that lines? SA, SB, SC, SD, and SE and SF, respectively. Full stop and right. According to Kepler's second law of planetary motion, according to Kepler's second law of planetary motion, according to Kepler's second law of planetary motion, according